Good afternoon, students. Whether my screen is visible, I'm audible.
Yes, sir.
Okay. Right. So, welcome to module number 41, the internal combustion engine subject. Uh, in the unit of 5, the modern technologies which is used in IC engines for the better performance, right? So, better performance in the terms of the noise control, right? Sorry, noise means the emission control and the fuel economy range, right? So last class we discussed about the common rail direct injection, right? Common rail direct injection system. We just given an overview, right? So in this class we are going to see about what are the components are there, right, in the common rail injection system, right? So just entering this class, just we can recall what are the terms we discussed in the last class, right? So the common rail is a fuel injection system used in diesel engines and basically work as the synchronized injection via the common passage, the common pipe, right? So compared to the conventional type of the diesel engines, conventional diesel injection systems, right? So it is a superior system for the fuel consumption and the exhaust gas emission operating system and the noise reduction, right? So these terms are superior in CRDI engines, right? Then the common rail technology is designed to improve for the atomized diesel fuel in the injection process, right? So it is having the very good atomization process, right? So during the high pressure, right? Then the traditional diesel engines must produce fuel pressure for every injection for the traditional diesel engines, but in CRDI engines, the pressure generates as the injection sequence and remains constant in the fuel line, right? So unlikely the single pumping systems, the pressure buildup and spraying and separated in the common rail system, right? The common rail direct injection system. While in a conventional diesel engines, the direct injectors operate at pressure. It's approximately 900 bar, right? So for the conventional diesel engines, the pressure so which is produced in the injector, right, by the injecting pump is around 900 bar pressure, right? But in the common rail system, but in the common rail direct injection system, distributes the fuel at the pressure of about 1600 bar, about 1600 bar. So here we can generate the high pressure, right? So we have to supply the high pressure fuel into the engine cylinder through the injectors, right? Then the ECU unit is a very important one here, right? So the ECU unit, electronic control unit, adjusts the high pressure. It's depending upon the various engine loads and the various engine speed conditions, right? So this injection process is accomplished by the high speed solenoid valves, right? So here we are using the uh, signals from the ECU to the other components. So we are using the device which is based on the electrically worked one, right? So here we are using the solenoid valves, right? So here we are using the high speed solenoid valves we are using in the injection process, right? So to obtain the fuel in a required rate to the cylinder, right? Then the advantages of the CRDI is that the pressurization and the fuel injection can be operated independently from the each cylinder, that is each other, right? So the amount of fuel is sent to the cylinder is adjustable, right? So it can be adjustable by the sensor sends to the signals to the ECU unit, and that ECU unit will adjust the flow, right? That unit will adjust the flow, right? So that unit will adjust the flow, and it will be sense the amount of fuel in the through the injector to the engine cylinders, right? Then here the new possibilities are the pre-spraying, right? So which is the perfect advantage of the new systems, right? So here the pre-spraying will be there, right? So these are all the reasons, right? So what I mentioned here, right? So that are the distance reasons, that are the reasons why we are using this type of the injection systems in nowadays engines, right? So our ultimate aim is we have to consume only the low amount of fuel, right? At the same time, the emission value has to be reduced, right? Various studies and various researchers, right? So the vehicles are using this type of injection system, that is CRDI technology, right? So it will burn the 25% less fuel than the conventional diesel vehicles, right? So these are we discussed, right? So these are the terms we discussed in the last class. So in this class we are going to see about the components, right? What are the components are there in the CRDI engine, right? So here we are using the various types of the components, various types of uh, the components, and the design and the trademark of the system design is there, right? So here I take an example of the Bosch EDC16 module, right? So in this module, the one of the main component is the high pressure pump, right? So the high pressure fuel pump, so one of the very important component for the CRDI engines, right? The high pressure fuel pump is located between the low pressure and the high pressure pipes, right? So here you can see this blue and this the low color, right? So it is the low pressure pipeline, right? It is low pressure pipeline, and the red will be the high pressure pipeline, right? So the high pressure fuel pump is located between the low pressure pump, low pressure pipe, and the high pressure pipe, right? So the basic function is to transmit the fuel to the system uh, at the required rate of pressure, right? At the required rate of pressure, right? Then the high pressure fuel pump is supplied by it is run by the electrical circuit, right? It is separately run by the electrical circuit, and this pump is produced, the fuel pressure is required for the high pressure injector, right? So high pressure injector, and it will be the high pressure injector to provide the ideal mixing of the fuel and air. It's directly into the combustion chamber, right? So through the injector, right? So the first device we have to remember is the high pressure pump, right? So where it is located, which is located between the two pipelines, right? So one is the low pressure pipeline and one more is the high pressure pipeline. Between these two we have to locate the high pressure pump, right? So the high pressure pump will transmit the high pressure fuel into the system, right? So here the pump is producing what are the pressure is required for the fuel injector, right? So that we have to generate and we have to supply here, right? And here we have one more important component, that is the fuel metering control valve. Fuel metering control valve is an important one, right? So which is located the back side of the high pressure pump, right? So you can see here it is the high pressure pump, it is located the back side of the high pressure pump, right? Then it controls the amount of fuel, right? It controls the amount of fuel, right? How much amount of fuel will be gets into the system, right? So that it will be controlled, and it will be controlled by the ECU unit, right? It will be controlled by the ECU unit, right? When there is no energy on the solenoid, so we are using the most of solenoid valves we are using here, right? So when there is no energy on solenoid, right, so the valve is open and the low volume of the fuel charging into the high pressure pump, right? So when there is an energy on the solenoid, there is an energy on the solenoid, so the valve is closed and the high volume of fuel is charging into the high pressure pump, right? So that's the function, right? Then the another one important component is the high pressure regulator valve, right? So here you can see, here we have a fuel pump high pressure control valve, right? It is called as the high pressure regulator valve, right? So here why we have to use the high pressure regulator valve is we have to control the high pressure fuel which is delivered to the common rail, right? Then it will sense the exceed fuel into the fuel tank, right? It will be sensed, you can see here, right? So it will sense back to the fuel tank, that is the excess amount of fuel, that is the excess pressure of fuel will be sent back to the fuel tank, and then it will be cool down the fuels before it's sending to the tank, right? So here we have a coolant unit, right? So here you can see it is the coolant unit, right? It is the coolant unit, right? So these are the main components, right? And here we have one more main component, that is the common rail tank, right? So here the common rail is there, no? So it is a tank, right? It is one type of the accumulator, right? What is the accumulator? It is a storing device, right? So the high pressure fuels will be stored in a common rail, and then it will be distributed into the engine cylinder through the injectors, right? So by the communication from the ECU unit, right? So here the fuel is sent to the common rail at the high pressure, right? Then the fuel is stored here in the common rail system, and it will be distributed by the injector, right? By the distribution of through the injector to the combustion chamber, right? So in additionally, this common rail will eliminate the vibration caused by the high pressure pump, right? So it is the main function of the common rail system, right? So it will eliminate the vibration which is caused by the high pressure pump, right? While from the high pressure pump, water, the high pressure fuel will be gets into the common rail system. So there the vibration will be arrested by this common rail accumulator system, right? Then here we have using the different type of sensors, right? So here you can see here a lot of the dotted lines will be there, right? So what are the dotted lines? So the dotted lines will be represents as a sensors, right? So these sensors, signals from the sensors will be gathered in a ECU unit, and then the ECU unit will be controls all the major components, right? So here the pressure sensor will be located in the common rail system, right? So here you can see the fuel pressure sensor, right? So here the sensor will be there. So the sensor will sense what is the pressure inside the common rail, right? So if the sensor sends the signal to the ECU unit, and then from the ECU unit, if it is required, we have to reduce the pressure, so it will send the signals to the pressure control valve. Then the excess pressure will be again sent back to the fuel tank, right? So here we are using the most type of sensors, right? So here we are using the plenty of sensors, right? So these are the components which is used in CRDI engines, right? So what is the major component? You can see here. So these are the common one, right? So the pump, right? So fuel tank and the pump and the fuel filter will be the common one, right? So here we are using the high pressure pump. It's an important one, high pressure pump, and the fuel metering control and the fuel sensor, then the control valve, right? So if here it's a cooler, right? So it is a cooler one, right? So this cooler cools the oil, right? If the high pressure fluid will be sent to the tank, right? So while sending the high pressure, surely it will have some high temperature. So we require a cooler to cool the high pressure fuel and cools the fuel, and it will be sent back to the cylinder, right? So these are the leak or the return. So leak back or a return passage, right? So the blue will be the right. So here the blue will be the return flow, right? So the blue will be the return flow, and the red will be the high pressure line, and this yellow will be the low pressure line, right? So here you can see the what are the components are there, right? So just we can see a video about this common rail system, right? Whether the components will be clear to you? Is it clear? The components are clear? Components என்னென்ன இருக்குன்னு தெரிஞ்சாப்பா? Clear? Hey, anyone reply? Okay, right, fine. Whether my screen is visible? Screen visible இருக்காப்பா? Okay, sure. Okay, right, fine. So here you can see it is a common rail system, right? So it is the high pressure pump, right? So it is the high pressure pump, right? So in this pump, how the low pressure fuel will be compressed, and how the pressure will be generated, how the pressure will be increases, that we can see, right? It is the fuel high pressure pump, right? So it is a rotary type of pump, right? So in this pump, what will happen? So once the rotor will be rotates, right? So here you can see once the rotor will be rotates, you can see the upper part, right? You can see the upper part will be reciprocates, right? Upper part will be reciprocates. Here the blue line will be a low pressure one, right? So here the blue line will be the low pressure one. So the low pressure will be comes into the system, and it will be pumped, and it will be supplied into the system to the high pressure liquid, high pressure fuel. So the upper part, it is the flow metering devices, right? It is the flow metering device. Here we can see, here the high pressure will be generated, here the high pressure will be generated. You can see here what are the components inside the pressure pump. So the low pressure will be comes inside to the pump, and you can see how it will be converted as the high pressure. You can see here. So the low pressure will be comes into this chamber, right? So once it will be, the low pressure will be there, and it will be all closed, and it will be compresses the fluid, and it will be converted as the high pressure, right? So here that function is metering function also, right? It will accurately it will compress the fuel, and the amount will be increases, the pressure will be increases. Here you can see the green will be the low pressure one, and it will be sent to the pump, and the high pressure liquid will be sent. This is the common rail, right? The central passage will be the common rail, and here you can see it is the pressure control valve, right? It is here it is the pressure control valve. Yeah, it is a pressure control valve. Once it will be receives the signal from the ECU unit, right? Then it will be controls the pressure, right? So it is the fuel injector. It is the fuel injector which injects the fuel, right, at a high pressure. So the red will be the high pressure one, right? So how the injector will be works means it will be solenoid one, right? So if the solenoid will get information from the ECU unit, then the injector will be works, right? So here at the top you can see here this here it will be energized, right? It will be energized by the ECU solenoid, right? ECU solenoid, then it will open its nozzle. It is the fuel injector. So it is suction, compression, power stroke. It is the power stroke. So here the red will be the pipeline, right? So the upper part from the common rail to the injector. So in the fuel injector, what are the terms are there? One is the fuel disc, and the solenoid valves. Right. So how it is a solenoid valve? It is a solenoid valve. It is the drum. So it will receive the signals from the ECU unit, and it will be injects the fuel. It will create a path. Right. So it will lift the fuel nozzle, and it will be sends, and it will be supplies the fuel. It is a fuel injector. Right. So whether that video is clear? Anyone?
Yes, sir.
Yes. Then here in this
Diesel
video,
drive system with the common rail system CRS-II from Bosch is an economic solution for passenger cars with motors up to about 90 kilowatts per liter. The solenoid valve injectors work with an injection pressure of up to 2500 bar.
right. So here you can see the one more video, right? How the common rail system will be works.
The rail injection system accumulates the necessary pressure required for injection of fuel inside the rail. Just like the EFI system with the gasoline engine, this system injects fuel into the cylinders by opening and closing the injectors in accordance with the electrical signals output by the ECU. Therefore, this system can finely regulate the injection volume and timing, thus contributing to highly efficient operation and clean emissions. Furthermore, because this system accumulates constant fuel pressure in the rail, it does not create sudden pressure rises and offers the advantage of quieter operation. Now, let's look at the system. Let's start with the sensors. Here's the accelerator pedal position sensor that detects the opening angle of the accelerator pedal. The airflow meter. The intake air temperature sensor. The turbo pressure sensor. The water temperature sensor. The crankshaft position sensor that detects the rotational angle of the crankshaft. The camshaft position sensor that identifies which cylinder is at TDC. And the fuel pressure sensor at the common rail, which detects the pressure inside the rail. Here are some of the actuators used in this system. The suction control valves, or SCVs, which are located on the supply pump assembly, control the amount of fuel that is fed to the supply pump. The electronic driver unit, or EDU, which boosts the injection signal from the ECU. And the injectors that inject fuel in accordance with the injection signal. The fuel is drawn up from the fuel tank by the feed pump located in the supply pump assembly. Then it passes through the fuel filter and is fed to the supply pump. The fuel becomes pressurized in the supply pump to reach the injection pressure. Pressurized fuel is fed into the common rail where it is accumulated. The fuel that accumulates in the common rail is distributed via the injection pipes to the injectors of the cylinders. Then the injection signal from the ECU opens the injectors to inject fuel. The fuel pressure that is created in the supply pump varies according to driving conditions. It is approximately 20 megapascals at idle and increases to as much as 135 megapascals during high load, high speed operation. Let's look at its internal construction. The supply pump contains an inner cam which is driven by the engine. On the inside of the inner cam, there are two sets of opposing plungers. Each set of opposing plungers is positioned at a 90-degree angle from each other. Each plunger operates independently. The tip of each plunger is provided with rollers that come in contact with the inside of the inner cam. The inside of the inner cam is oval. The rotation of the inner cam pushes the plungers via the rollers, which effectively pumps the fuel. The use of the two opposing plungers in this manner minimizes the drive torque fluctuations, which makes for quieter operation. The fuel that has been sent by the feed pump flows past the suction control valve, or SCV, and the check valve. The fuel is then pressurized by the plungers and flows via the delivery valve and is fed into the common rail. The SCV regulates the volume of fuel that enters the supply pump plungers. During the suction stroke, the longer the SCV remains open, the greater the volume of fuel that enters the pump plungers. And because a large volume of fuel is pumped, the fuel pressure becomes high. During the suction stroke, the shorter the SCV remains open, the smaller the volume of fuel that enters the pump plungers. And because only a small volume of fuel is pumped, the fuel pressure becomes low. In this manner, the ECU controls the opening of the SCV so that an appropriate fuel pressure can be reached. Let's watch on an oscilloscope to see how the SCV is controlled. To easily monitor the operation of the SCV, let's see the electrical current that flows through the SCV. The SCV signal is shown at the top and the fuel pressure sensor signal at the bottom. Here's a comparison between the no load condition at 1500 RPM and the load condition at 1500 RPM. It's evident that in the load condition, the SCV remains open longer and the pressure in the rail is higher. Thus, according to the signals received from the sensors, such as those of the accelerator pedal or the engine, the ECU controls the SCV to regulate the fuel pressure that is needed for the particular driving condition. Then, the resulting pressure is fed back to the ECU by the fuel pressure sensor in the rail. The common rail accumulates the fuel that has been highly pressurized by the supply pump and distributes it via the injection pipes to the injectors of the cylinders. A fuel pressure sensor is provided at one end of the common rail to detect the fuel pressure in the rail and to send it as a signal to the ECU. A pressure limiter is provided at the other end, so that in the event of a system malfunction, if the fuel pressure rises abnormally, the pressure is relieved mechanically. On receiving the signal from the EDU, the injector opens its nozzle to inject the fuel that has been accumulated in the common rail. Let's look at its internal construction. The fuel that is fed from the common rail separately enters the control chamber and the nozzle portion of the injector. In this state, the nozzle is closed because of the pressure of the control chamber and the spring force pushes the needle down. On receiving the signal from the EDU, the solenoid valve above the control chamber opens. Then the pressure in the control chamber decreases, which causes the pressure at the nozzle to push the needle upward, and the nozzle opens to inject fuel. A small trimming resistor is installed to each injector to compensate for production variations. The ECU recognizes the resistance and applies correction for injection of each cylinder. How does the ECU determine the injection volume and timing? Let's first look at the injection volume. The ECU calculates the basic injection volume and the maximum injection volume, and whichever is smaller is determined to be the actual injection volume. The basic injection volume is calculated from the engine RPM signal and the accelerator pedal position signal. From these two signals, the injection volume that is required by the driver is calculated. On the other hand, the maximum injection volume is calculated based on the actual intake air volume and temperature that have been obtained from various sensors, such as the fuel temperature sensor, in addition to the engine RPM signal. Thus, a volume of fuel that can theoretically be burned completely is calculated. These two calculated values are compared, and the ECU determines the smaller of the two to be the actual injection volume. In this manner, the ECU is always taking the actual intake air volume into consideration to determine an optimal injection volume that does not generate black smoke. In particular, in the 1CD FTV engine, the changes in the intake air volume during the transient state is detected by the airflow meter in order to correct the injection volume. Now, let's take a look at the injection timing. The injection timing is determined with the basic injection timing that is calculated based on the engine RPM signal and the accelerator pedal position signal to which corrections are made. For the intake manifold pressure signal, and the water temperature sensor signal. Now, let's take a look at the pilot injection. A pilot injection is a small amount of fuel that is injected before the main injection. Accordingly, when the main injection starts, the fuel that was injected beforehand is already burning and serves to smoothly ignite the fuel of the main injection. As a result, a sudden rise in the cylinder pressure during the combustion stroke is restrained, thus enhancing quieter operation of the engine. Let's take a look at the actual injector signals on an oscilloscope. To easily monitor the operation here also, let's see the electrical current that flows through the injector. It is evident that the pilot injection takes place before the main injection. To enable the ECU to correctly determine the rotation position of the supply pump, the marks on the pulleys must be aligned while installing the timing belt. The pressure of the fuel becomes extremely high in the common rail. Therefore, pay close attention when installing the unions of the injection pipes or the inlet pipes. If any operation that causes the contact of the union to change, such as the replacement of parts, make sure to replace the pipe. Details, refer to the repair manual. After tightening the union, make sure to check for leaks with the fuel pressure raised. The fuel pressure can be raised by conducting an active test using a handheld tester. In addition, one of the active tests that can be performed is the power balance test, in which the injection to the cylinders is cut off one cylinder at a time. The pressure limiter of the common rail has been precisely adjusted at the factory. Therefore, any adjustment or replacement in the field must never be done. During its installation, the fuel pressure sensor deforms through tightening in order to ensure proper sealing with the common rail. If the fuel pressure sensor or the common rail must be replaced, they must be replaced together on an assembly basis because reusing them causes fuel leaks.
Right. So இந்த வீடியோ பாத்தீங்களா, தெரிஞ்சது என்னன்னு? Is that video is clear?
Yes, sir.
Right? So that's the working of the various components, right, which is present in a common rail injection system, right? So here you can see they mentioned as, here the high pressure pump will be mentioned as a supply pump, right? Supply pump, right? So or a supply control pump, right? That is called, they called us, it is a SCV, right? That is the supply control valve, like that they mentioned, right? Then the fuel metering device, then it is the pressure control valve, right? Then the fuel sensor, right? Fuel sensor, right? So like that they explained, right? So what are the components, what are the major components are there, right? Then how the injector will be works, right? So that term they discuss, they explained, right? So is it clear? Working life தெரிஞ்சப்ப உங்களுக்கு இப்போ, so now you can get a better idea about the common rail system, right? Is it clear? Do you have any doubt on that? Do you have any doubt on that?
No, sir.
No, right? So this is about the common rail direct injection system, right? So in this common rail direct injection system we are using the diesel as a fuel, right? So the same, but we are using the different fuel, that is the gasoline fuels or a petrol fuel, right? So that injection method is called GDI, gasoline direct injection. So that we can see in the next class, right? So for our fifth unit we covered two topics. One is the HCCI engine and second one is CRDI engines, right? So do you have any doubt on that two topics? So why? Because last class I explained that HCCI engine, but somehow some technical issues, right? So we missed a 15 minutes lecture. That's why I'm asking you. Or otherwise, once again I can explain that HCCI later weeks. Do you have any doubt? Whether that video having a good sound quality, I believe. அந்த சவுண்ட்லாம் நல்லா கேட்டுச்சாப்பா உங்களுக்கு அவங்க சொன்னது?
Yes, sir. Yeah.
Okay, right, fine. So do you have any doubt? Means you will stay back, otherwise you can leave the class. Thank you.